You're saying volunteer. Okay. And under coverage. What else? Non-responsive bias. Okay. What
Question order.
Because
question order bias? Then there is an. Is there something similar to this? Do you have answer order bias also?
How? Like what is that?
Let me write something like that. What else?
non-responsive volunteer is, I think, very similar.
Okay. Very similar or little similar or what else? What else?
What my understanding of volunteer was.
आपने नहीं देखा?
Self.
Where are your tags? At least people who are offline, they are stuck. People who are online, I'll ask them also. But I can't see anyone. Okay, I should tell you. Chalo, let's see.
Last time ना ये
Dikshant, could you Dikshant गला platform पे कर.
जैसे उनको
Dishant.
एक छोटी स्क्रीन में दिखता है. Like someone wants to recap, वो वाला स्क्रीन दिखता है.
Shilpi.
इसमें तो क्या है?
शिल्पी अग्रवाल.
अगर बड़ी स्क्रीन कर ले तो नहीं दिखता. बट रिकॉर्डेड लेक्चर्स भी
ये जिनका नाम लेना आप कहीं पे नोट कर सकते हैं.
Can they hear us?
And minus 2 in CP. Very wonderful. More the merrier. The party is getting. But, Vedanta, I was calling your name. Did you get a chance to work on the assignments? Did you get a chance to work on the assignment? You're on mute.
ये वाली सबसे अच्छी.
Karan साहब mute पे आप.
ये से किया है. अभी
Did you get a chance to work on the assignments?
So what assignments?
There were 3 assignments that we had in the last class. One assignment was learning about biases. The other assignment was working on a data set and finding out the descriptive analysis of the data set. And the third assignment was creating a simulation. What was it? Creating a simulation for Monte Hall problem. But चलो समझ में आ गया हमारे. Anyone who's online has done it. Anyone who's online has done it. You can unmute and tell me whether you've done it or not. I'll tell you one thing. You have marks for CP, class participation. And it is written in the COT that the marks are for attendance, and in brackets it is written attentiveness. And also there are marks for assignment, right? Now if I ask someone anything, if you're not able to answer, you lose marks. Me being a very generous person, I start with full marks. Everybody has got full marks in attendance and attentiveness in CP right now. But if I'm asking questions and you're not able to answer, you lose marks. Fair. Similarly for assignment. So I'm not asking you to submit these assignments. That does not mean that you don't have to. So there are 3 assignments that we have talked about. When the course ends, so already 40% is done. When the course ends, all of you will have to submit all the assignments together. Right? So that means if you're not working on these assignments now, I will make sure that you do not get enough time at the end of the 5th class to do it and submit. So you'll not be able to do that. Then you will lose marks again. There might be assignments which I will be asking you to do in groups. If you're doing it in groups also, let's say if there are 3 people in the group, everybody has to put the entire assignment in their own submission as well. So I'll make 3 copies of the same assignment. I generally put it in, turn it in to check plagiarism of any sort, AI generated content. Right? I'm not worried about, I don't want you to write a lot. I just want the material. That's it. Right? So the idea is that you do it. If you don't do it, then it will be difficult for you. Because assignments is 25 marks if I'm correct, and class participation is 20. So 45 will be gone just like that. And you know how it is about the quizzes. There'll be surprise quizzes.
So for this Monty Hall problem, I think the entire assignment could be plagiarized, right? Like it's okay.
Yeah.
You just need to write 2 lines, 3 lines about the Monty Hall problem, whatever you're getting from the GPT. That will be AI generated content only because you're doing it on GPT. That I understand. Right. In fact, for your data analysis also, the Netflix problem or the YouTube problem or any other data that you have taken, there also if it tells me that the data is taken from somewhere, I am happy. No problem. I just want to see how you analyze. What have you done on Excel? So you'll be asked to submit Excel. One Excel with, so let's say if I give you more assignments, so the same Excel you have to use, you just have to name the sheets. That's it. Right? But believe me, you will not get time to finish it later on. You will not get time to finish it later on. That's why my request is, and it's a humble request, to please keep doing it so that you don't suffer later. Right? You can tell me if I'm being unfair and if you don't like it. Bolo bhai. You think I'm being unfair? No. तो एक भी इंसान नो बोल देता है ना तो मैं मान जाता हूँ कि हाँ बाकी सबको फिर सुनना ही नहीं है ठीक है जी राइट व्हाट विल डू इज I'll ask you guys to talk in between. First of all, biases, right? This is survival bias. Now, those of you who have read it already would know. Are there any more biases that we have missed? There are many more.
Self-selection.
Self-selection bias, okay. Okay.
Social desirability.
Social desirability bias. Oops. What else? What else? Madam, did you get a chance to read on biases?
But I remember all these.
You remember all these? All of them you have. What is undercoverage bias? चलो नहीं पढ़ा है अरे मेरा आदमी चला गया लिखने वाला नोट करने थे you have read no wonderful you've read how many of you have read actually 1 2 3 4 5 6 okay do one thing those of you have not those of you have read I'll ask your names again okay those of you have not go to Qualtrics surveys website Qualtrics is a website which you use to design surveys, just like a SurveyMonkey and other websites. Qualtrics has a wonderful article on biases that can creep in when you are doing survey research and when you are doing sampling. Now, these are all known as sampling biases, right? And the list can get longer. Now, mostly what you would have read, and if you have read, what you would have read is that there are some very clear categorized ways in which these biases are generated. One very clear category is how you're selecting people, right? How you're selecting people. And you would have read, let's say I am talking about doing a research on people who are having problems with using technology. Using tech, let's say people who are having problem using GPT. I want to do a survey. I want to find out what are the problems that people have when they use GPT. Now, in order to do so, what I do is I go and get data in a manner where I'll not get respondents who use GPT a lot. Let's say I am doing it offline, sitting outside a chai tapri. Possible that I might get a lot of people who do not even use GPT, right? Let's say I'm talking about the problems that people face while writing letters and I'm doing this over email. I'm sending email to people and I'm asking them to reply. Now, these people do not even write email by hands manually. If the people are not writing emails manually, the response that I'll be getting, if the people are not writing letters by hand and I'm sending it on email, the response that I'll be getting will be from the people who are writing emails mostly. They won't even know what are the problems that people have when they are writing letters. So there's a problem in selection. There's a problem in defining how I'm collecting data from and where I am collecting the data from. Right. Also, when you talk about selecting people, right? Voluntarily, people are coming in, they are filling the data. These again might not be from the right population or the right sample that I need, right? These are the people who want to fill the survey. Might not be something which is desirable for me. I am talking about non-responsive bias where I am not getting responses from people, right? To whom I have floated the survey also. You will be surprised. Generally, in research, we say that the response rate remains somewhere around 4%. Anything under 4% is poor. I'll tell you about my research when I did my thesis. I had to collect data from SMEs, small and medium enterprises. I floated my survey to almost 3 lakh SMEs. 3 lakh. And can you imagine the number of responses that I got? Bataiye.
15,000?
15,000.
Hundreds maybe.
Hundreds. In the first go, I received 19. 19. Then I floated another. Then I sent them a reminder. Partho, this, what ये भी बोला Amazon कूपन भी देंगे, है ना? But उसके बाद में भी मेरे पास में total I could reach to was some 31, 32.
3 लाख लोगों को भेजा कैसे आप?
तो मैंने I got a live internship floated in a MBA institute, Jaipur Institute of Management, if you would have heard. So I floated a live internship there, and I had around 80 students. I used to ask them to send it daily and then give me the report. And then I made them call these people also. The first time mein nahi hua, when it did not work, I asked them to call these people. And by the way, these were SMEs only. I got the data from somewhere which was on SMEs only. Then I approached Quality Council of India, QCA. QCA is the firm that has introduced zero defect, zero effect. I don't know if you've heard about it or not. There's a policy of the government of India where SMEs are certified on the basis of their quality and their environmental impact. And QCA is the organization that was doing it. So I approached QCA. They had some 16,000 registrations. Now these were the SMEs. These were 16,000 SMEs which were working on quality and environment both. And they paid a fee. So they were alive. I approached them. I started going to their meetings where 200, 300 SMEs were attending these meetings. Now I was doing it offline. When I did offline also, just imagine I'm giving survey to 200 people. I got different kinds of responses which I can't even tell, right? With drawings on the survey, people writing beautiful words on the survey. Only a few, very few of them used to fill it religiously, right? You can understand the kind of problem that you have with sampling, right? Sampling specifically where you want people to be responsive, where you want people to tell you the things that they are having now. One thing is on the basis of the sample that you are covering, right? The sample that you are covering from the populations. People might not respond, people might not be willing to answer a few questions. When people are not willing to answer a few questions, there might be some specific reasons behind it, such as social desirability bias. People do not want to answer a few questions. Maybe something personal. Let's say if I'm talking about a disease, let's say I talk about depression. I'm doing a study on depression and I ask you questions, let's say, that do you have problem sleeping? Is there a loss of appetite? These are some of the symptoms of depression. People who are not willing to talk about it will not even fill the survey because then they have this fear that people will get to know that I am suffering with something or I am having a certain situation in my life or whatever. Also, there is a problem which is known as there's something which is known as naturalistic inquiry and there's something known as there's a validity that we talk about where people would want to tell you what you want to hear. So when we are talking about sampling does not only cover surveys. Sampling also covers sometimes interviews. So I did a sampling and I'm now interviewing people. Let's say I want to understand about the perception of my brand. Now when you go and talk to people, let's say if I have built this and I am showing it to you, look at this pen, tell me how it is. What is the look and feel? You will never ever tell exactly what you feel about this pen when I am asking this to you and I'm standing there. Right? This problem is known as a problem of ecological validity. Ecological validity says that people under a certain situation will not behave as they would have behaved really in a real life situation. For this, there was an experiment done. A lot of people were asked to sit in a plane. Aeroplane mein baithaya ji. And then they were told that today we'll be doing a mock drill where we'll be giving you instructions in a case of emergency landing, how you should be behaving. And they were told that, there are two doors on this side and that side. You have to follow the light and you have to do this. Nobody will push each other and all. And then then they were told there was a vibration in the plane and they were told that the plane is about to crash. Now you have to get out of the plane. Everybody did it perfectly. Nobody is pushing. You go first, Arey, please. Do you think that they would have behaved the same way when there was an actual crash? No. Fire drills for that matter. If we do a fire drill today, I am sure all of you will be like, "Arey, sir, आप पहले चले जाओ, आपकी जिंदगी ज़्यादा ज़रूरी है शायद." जिस दिन आग लगी, ऊपर से जा रहे होंगे. So this is the problem of ecological validity, where people behave in a certain way when they are put in a certain condition. Now, when you are interviewing people, when you are doing surveys, you know that you are being interviewed or you are being surveyed for a specific reason. And there's a bias that comes in your mind where you would want to help the researcher, irrespective of whatever it is, irrespective of whether you really want to help or not, but then you end up answering the question in a certain way which the surveyor is asking. Also, there's a bias known as recency bias, right? Irrespective of how our first class went, second class, third class, fourth class, if at the end of the course somebody asks you, and let's say the fifth class is horrible, where I, do things which you won't like and all, right? I punish you in all the ways possible. After the fifth class, if somebody asks you that how was this course, you'll be like, worst of the person we've ever met. Why? Because there's a recency bias. You forget what happened. And this is evident everywhere, in all the relationships, in all our experiences. You go to an amusement park, the first, second, third, fourth ride you enjoy a lot. But in the rides that you have towards the end, let's say you start feeling nauseatic and you don't feel good and you end up vomiting. Your experience will always remember as an experience where you ended up vomiting. Right? So that's where, and there's a saying also, Ant bhala to sab bhala, where things have gotten better at the end, everything is goodbye because of recency bias. So recency bias kicks in. And recency bias is again a bias which is there. Now you talk about the way you are putting questions, right? The way you are putting questions in the survey. Survival bias is also related to the way you are selecting the sample only. So one major problem in sampling comes from how you are selecting the sample. Another kind of biases that creep in are majorly from the way you are putting the questionnaire. Now, when you put questions in the questionnaire and you will see it, if the question is long, the response rate goes down. For a short questionnaire, maybe the response rate is high, but as the questionnaires length increases, the response rate also goes down. Another problem is people who are in this habit of just 2, 2, 2, 2, 2, 2, 2, 2, 2, 3, 3, 3, whatever, right? Why does that happen? Because of the questions again. And also the order of questions has a lot of bearing on how somebody is answering. Let's say if I ask you, let's say I'm doing a survey on daily habits. Now there I ask you that what time do you wake up in the morning? Now somebody who wakes up, let's say late, 12 p.m., right? For some of you that still might be early, but let's say 12 p.m. and it is late. So if somebody is waking up at 12 and I ask you how, on a scale of 1 to 7, 1 being very early, 7 being very, very late, where do you rate yourself? And let's say somebody says 5 or 6. Next question is, how do you feel in the morning? Now that person who's waking up at 12 very, very late, he's just felt very, very late. Now that person would be feeling in his mind, yeah, I'm late. And now the next question is, how do you feel in the morning? How can I feel good about it? I feel bad about it. Why? Because you've just answered one question which was negative. And because of that, the second question also you have answered in the similar fashion or similar manner. How do you overcome this particular problem? You jumble up the questions. You change their order so that the questions. Another thing is, when you do surveys, and I'm sure Everybody will either be doing surveys sometime in their lives or will be having their subordinates doing a survey, and your job is to catch where things can go wrong. There's one problem in surveys which is known as double barrel questions. Double barrel questions are questions which are measuring two things. Double barreled. Now, the same question that I asked you just now, how early you wake up in the morning, and the next question was, how do you feel? Let's say I club them and I say, how early you wake up and what do you feel about it? Now you don't know how to answer this question on a scale of 1 to 7 because there are two things being asked. Maybe I get up late, but then I feel very happy. I have no way to answer this in one question, right? Or in one particular scale. Double barrel questions are the questions where you are measuring two things. Do you feel confident and happy? Bad question. Should never put and. And the easiest way to find double barrel question is Control F in your survey and search for and. Or these things should not be there in your survey. No double barrel question. Another way of finding these things out is you always, if you're doing it online, you put a tracker on time. Put a tracker on time, fill the survey yourself, ask somebody to fill it in front of you. So let's say if I'm asking him to fill the survey and he's taking 2 minutes, I took around 1 minute, let's say 56 seconds. He's taking 2 minutes, 5 seconds. So I know that the average time is around 2 minutes for filling out this survey. Now he fills it in 7 seconds. Not possible humanly to read the entire survey in 7 minutes, forget about filling the responses, but then he just clicked and so I'll discard this particular response. Also, you put questions which are negatively worded, right? With a reverse scale. What is a reverse scale? I am asking questions such as, let's say if I'm talking about this class and I want you to rate how effective is the class. So I ask you on a scale of 1 to 7, how was the class conducted in terms of communication? On a scale of 1 to 7, how was the class conducted in terms of delivery? On a scale of 1 to 7, how was the class conducted in terms of flow? Then I say, on a scale of 1 to 7, how was the class conducted in terms of content? And I reverse the scale. So earlier I was saying 1 being bad to 7 being good. Suddenly I say 1 being good, 7 being bad. So if somebody is paying attention, they'll understand what they're filling. And for this particular question, if somebody has answered 7777 here, for this particular question, it should be 1. But if somebody is filling 7 here also, that means that the person is not paying attention and is just putting the answers for the sake of putting them. So this is another way of finding out whether the respondent is paying attention or not. Believe me, there have been people who have been putting questions such as, the color of sky is grey, black, blue, red, green. And because people are answering in a certain order, they end up filling black or whatever, or red or grey or whatever. Right? So a newborn has no teeth, yes or no? And people fill yes. Oh, sorry, no teeth is yes, but people don't fill no. People don't fill yes, people fill no. So you need to put such questions in order to. Questions might be a few questions which are not related to your study at all. These questions are just there to find whether the respondent was attentive or not. And first thing that you do is go to the survey, look at these questions. People who have answered sky is black, get them out, right? Because if you won't, it is going to hamper your results. It is going to have a negative effect on the findings of the study, and your study might go for a toss. So these are few of the ways in which you have these biases, and there are more biases. So I would request you to, even if we spend entire 2 hours talking on biases, still we'll not be able to cover all the biases. So I am requesting you again to go on this Qualtrics site and read about because they have covered it. I have, I've gone through a lot of articles also and a lot of other sources, but then the coverage there is a little wide, right? So go through that. Now, today what we'll do is, in the last class, we covered the basics of statistics. We started with descriptive statistics, inferential statistics, predictive statistics. We talked about descriptive statistics. We discussed about central tendency, which is mean, median, and mode. Then we talked about dispersion, which we generally find out using standard deviation, variance, range. Now, did we discuss coefficient of variation in the last class? Okay. In the last class, I told you that I hate something in dispersion, which is the standard deviation. Why do I hate standard deviation? Because standard deviation being high means the consistency is low. Okay. So if I am, what I was telling you that standard deviation is bad. Standard deviation is bad. And standard deviation being high means consistency is low. But the problem is, and you tell me, let's say I have two data sets. I have two data sets where I say that I'm looking at income data. Now, there is one set of income data where I'm talking about people who have, these are from different countries, by the way. Let's say I'm talking about income data from India and US. Right? In India, the mean income, let's say I'm talking about a specific kind of people working in a specific industry, let's say IT industry or education industry, let's say professors. Right. In India, the mean salary of people who are teaching MBA courses is somewhere around, let's say, 40 lakhs. Right? In Indian rupees. Whereas if I compare it with US, it starts somewhere around 1.2 CR. My handwriting is very good.
Confirmation bias.
पहले अच्छी हुआ करती थी जिस दिन मेरी PhD हुई मैं डॉक्टर बना मेरी handwriting एकदम से गिरती हुई but it's okay now these are the two things that we have
आप लोग अपनी पैकेज बता दीजिए सर confirmation bias पैकेज बता दीजिए
नहीं मेरा नहीं
confirmation bias
इतना तो गवर्नमेंट में मिलता है so now you have these two let's say right these are the mean salaries that are there. Now, what if I tell you that the standard deviation is same at both? Standard deviation here is also, let's say, 10 lakhs, and standard deviation here is also, let's say, 10 lakhs. What does it tell you? Which data is more consistent?
US
US data is more consistent.
and Indian data.
Why?
Because on a scale, matlab 10 lakh compared with 1.2 crore is
So he's comparing 10 lakhs with 1.2 CR and he's saying, if I look at the ratio, this ratio is very, very low. Ratio is low or high?
low.
depends
10 lakhs divided by 1.2, it will be low, otherwise it will be high if you are changing the numerator. But then what he's trying to say is 10 lakh changing in 40 means that the range is, let's say, I'm just talking about one standard deviation here and there. So that means you're talking about something around 30 lakhs to 50 lakhs here. But here you're only talking about 1.1 CR to 1.3 CR. Now, if I talk about CRs, right, that is 110. If I am to put it in lakhs, 110 to 130, and this is 30 to 50. This 20 difference that I'm having is in between 30 to 50 where the numbers are low. But then this 20 difference is between 110 to 130 where the numbers are very, very high. So if I look at it from another angle, what I feel is that the change is not very, very high here, whereas the change is very, very high here. Yeah, right. I can write better actually. I'm not that bad. It's looking really bad. How do I erase this? Oh yes, I got it. It's okay. आप बताइए तब तक बात कर लेते हैं. So, one thing is clear that the magnitude itself does not make a lot of sense. If I'm only talking about standard deviation and I talk about standard deviation in the salary and I say there are two data sets where the standard deviation is 10 lakhs. You end up saying that, oh, both have same standard deviation, both are similar. Then you end up being wrong because you did not look at the mean. But when you start looking at the mean, it starts making more sense. So coefficient of variation, coefficient of variance is something that tells us this particular thing, which is that coefficient of variance is nothing but a ratio of standard deviation and mean. And how do we write it? We say that coefficient of variance is standard deviation divided by mean multiplied by 100. Now, in the first case where our standard deviation was 10 lakhs, mean was 40 lakhs. What do I get? 25%. In the second case where my mean was 1.2 CR. So there also 10 divided by 120 multiplied by 100. Right? Yes or no? This is around 8%. around 8%, let's say 8 point something. Now I can tell that the coefficient of variance is very low for this one in comparison to this one. And this is actually more spread in comparison to this. Now, what is the good value? Anything which is below 10 is very, very good for us. If I have a coefficient of variance under 10%, I'll say that the data is very consistent. If it is 10 to 20, I'll still say that the data is okay-ish consistent. 20 to 30, but I'll accept it. 40 also I'll accept. I'll accept. But anything above 40, coefficient of variance going above 40 is non-acceptable for me. That means that the variance is too high in the data. Anything below 10 is wonderfully well. Wonderfully well. Anything in between 10 to 40, I might have varied degrees of acceptance, but then still I might not be very happy with 36, 34, 30, but I'll still accept it. But anything above 40 is a strict no-no. Right? Coefficient of variance. You wanted to ask something? Okay. We missed this in the last class. Now,
The data is bad.
the data is bad. It is having a very high standard deviation. Now, with very high standard deviation, all of us know what happens. So, if it is under 10%, maybe the data will look like this. But if it is 40%, 50%, the data will look like this. Right? Data is getting stretched too much, the standard deviation is very high. And I don't want to do anything on this because things are going very haywire, right? Things are going a lot on the edges and lot stretched.
Change the variable.
You need to either collect more data or you've done some mistake in collecting the data, or maybe the assumption that the data follows a normal distribution itself is wrong. The data might not be normal.
I think my thing, it was 125% and 40%. Like
125%.
rainfall.
Standard
Standard deviation is 117 and mean is 77. So then
should not happen. That means there's an outlier which is pulling your data towards one side. So you remove outlier and do it again. Okay. One thing is, and it's a rule, by the way, when you have outliers and if you're able to identify the outliers, you remove the outliers and then do the analysis again always. You would not want to have outliers sitting in your data. You would want to remove the outliers always. Because one outlier, we discussed it in the last also, one outlier, let's say if I'm talking about the mean age of this class and there's somebody who has had the elixir, remember the example? Who's living for eternity. Because of that person, the mean will go for a toss, the standard deviation will go for a toss, everything will go for a toss. So it's better to remove that person and then do the analysis again. You remove the outliers and then do the analysis again, it will improve. It will improve like anything. Right? Now, after doing this, we also started discussing about skewness and kurtosis in the last class. Everybody is fine with skewness and kurtosis, right? And then we started discussing about little bit about probability and permutation combination towards the end. Very little of PNC, but then I just want you to remember these formulas. One formula that we looked at was NPR and NCR. Remember the formula for NPR? We discussed this. What is that? N factorial divided by?
Minus R factorial.
Wonderful. N minus R factorial. And what is NCR?
Factorial.
Same formula that we have here. Only one thing gets added.
Minus factorial.
N factorial divided by N minus R factorial multiplied by R factorial.
Okay.
Now, today what we'll do is we'll do something very interesting, right? And I want you guys to be introduced to a few of our friends, right? Why am I calling them as our friends? Because we'll be using them. And whenever we talk about hypothesis testing, right, there are a few important things that we should know about hypothesis testing. That hypothesis testing is of two kinds. Why am I going to hypothesis testing? Because I want to set the foundation for this class. What is a hypothesis? I discussed it in the last class a little bit. Any testable statement. I just introduced that what hypothesis is. Hypothesis is any testable statement. Any statement that I can test. But now the problem lies here. That statement that you are testing, and if it's a quantitative statement where I'm saying that let's say the mean age of this class is this much. Pepsi claims that they have at least this much in their bottle. Maruti claims that the new engine that we have developed gives an average of, let's say, If the mileage of, let's say, 30 and above, right? Now, how will I test this? In order to test this, I'll collect some data, right? They're saying that the mileage of a new engine is over 30 kilometers per liter. Now, in order to test this, I will have to collect some sample. Now, when I collect the sample, the kind of data that I get is very, very important. Now, what do I mean by kind of data? Whenever I talk about data, data has different characteristics depending on where am I getting that data from. And you will realize it very soon. I am tossing a coin. What kind of data will I get? Head or tail, head or tail, head or tail. I'll keep getting the same kind of data multiple times. Either I'll be getting head or I'll be getting tail. This is one example. Head, tail, head, tail and all. If I do it 2 times, then what will I be getting? I'll be getting either head, right? Tail, head, tail or tail. These are the only 4 possible outcomes if I'm doing it twice. Right? If I'm doing it thrice, I'll have 8 possible outcomes. But again, all will be either heads or tails. Right? And now, let's talk about something else. IPL matches are going on again. Right? There, let's say 2 teams are playing against each other. Who are the teams that were playing yesterday? Punjab and CSK. Right? There are only few possible outcomes. Either Punjab will win or CSK will win. I'm removing the possibility of rain and all, okay? I'm saying if there's an outcome, either this or that. So there are only 2 possible outcomes. There are only 2 possible outcomes. When you're tossing also, there are only 2 possible outcomes. When you're playing a match also, there are 2 possible outcomes. Let's talk about business. I am manufacturing these pens. Now, the pen will be as per the dimension which I have to manufacture, or it will not be as per the dimension that I have to manufacture. There might be some tolerance, some issue with my machine which is producing faulty pens which are not as per the dimension. Again, pass or fail. Pen will either be pass or fail. Let's say I have a restaurant. In the restaurant, the customer will either be happy or unhappy. Satisfied, dissatisfied. You must have rated a lot of times satisfied, dissatisfied. Right? On Zoom meetings, this and that, every time it asks you. Translation, it asks you satisfied, dissatisfied. So this kind of data that I'm talking about, my friends, is a data where there are only 2 possible outcomes. Only 2 possible outcomes are there. And the probability of success will be defined as P. So if there are only 2 possible outcomes, let's say I am a fan of CSK and I say CSK wins, success for me. There will be some probability of CSK winning. Similarly, when I'm tossing the coin, I say I want heads. Right? If head comes, I win. So that is also a probability of success for me. All of you know it is 0.5. In CSK's case, I don't know how much is the probability of CSK winning versus Punjab case. But for head and tail, I know. Right? If I'm talking about producing these pens, I know that the yield of this machine is like 99%. Yield means out of 100, how many will be produced in the right manner. So if it is 99%, I know that the probability of success is 0.99. Am I making sense? So I have only 2 possible outcomes, and these 2 possible outcomes, well, I'll define success, and the probability of success will be P. Now you tell me, what will be the probability of failure?
1 minus P.
1 minus.
1 minus P. This is also fine. 1 minus P. My handwriting is seriously not this bad. Huh? I don't know what it happens. I'll show you my notes. It's not this bad. Don't judge me. So you have P and 1 minus P as the probability. Last thing and the most important thing is that these, if I'm doing it multiple times, if I'm doing it n number of times, the trials will have to be independent of each other. Now, what do I mean by this? If I'm tossing a coin, independent trials. If I'm tossing a coin, whatever I get on the first toss, will it have any bearing on the next toss? पहले वाले में हेड आ गया जी, इसका मतलब दूसरे वाले में टेल ही आएगा? नहीं आएगा, जरूरी नहीं, कुछ भी आ सकता है, हेड या टेल. आज पंजाब और सीएसके का मैच हुआ, पंजाब जीती, कल सीएसके लॉस्ट. Does it mean that the next time also CSK will lose match? Does not really mean that. First pen that I produced, it has got no bearing on the next pen being produced. Right? If you are able to tell that the trials are independent of each other. So let's say if I'm picking students, Now I say a lot of you are wearing black. 1, 2, 3, 4, 5. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Out of 14, 5 people are wearing black. What is the probability? I say success for me is getting somebody with a black shirt. Out of 14, 5 of you are wearing black. And I've defined number of. If I'm finding somebody with a black shirt, I define it as success. What is the probability of success for me?
5 by 14.
5 by 14. If I pick a person, randomly I just go around and I touch a person, and whether that person has black or white, whatever, I just check and I say, okay, sit down again. And I do it again. I'm not sending that person out of the class. The probability will remain the same every time. That means it is an independent trial. But if I send the person out, let's say in the first go, I found somebody with a black shirt and I sent the person out, what will be the probability of finding
4 by
another person?
4 by 30.
4 by 30. So the probability has changed. That means that these are not independent, these are dependent trials. I am strictly talking about independent trials. Right? Characteristics are clear of this data set. I'm talking about a data set where I am having n independent trials. In each trial, there are only 2 possible outcomes, one being success, the other being failure. Success is defined as P, failure is defined as 1 minus P. Such kind of data sets are known as or are known to follow a binomial distribution. This is known as a binomial distribution. Now, what is happening in a binomial distribution and what do we get from this distribution? Right? You want to look at a few questions? Want to do a few questions? You want to look at the formula or just want to do it on Excel? मैनुअली भी देखना है कि कैसा दिखता है या सिर्फ एक्सेल पे करना है? एक्सेल
मैनुअली देख लेते हैं.
देखना है तो देख सकते हैं, अदरवाइज वी कैन मूव टू एक्सेल डायरेक्टली. मैनुअली 2 मिनट में देख लेते हैं. देयर इज नो हार्म, अदरवाइज यू विल से कि क्या पता इसको आता ही ना. Right. So, people who are online are able to see my screen at least, right? If I open Paint and do it on Paint here. Please, that's not. Right. Now, I want to read this. You can't.
So we can't see this.
You can't see? You कैसे देखेंगे? एक बार I was teaching IRS officers. IRS officers का एक MDP होता था. I used to do it every year. So there was a senior officer, senior IRS officer. I was showing something on the slides. He said, I can't read. I said, I'll zoom it a bit. So I zoomed the slide a little bit. He still said, I can't read. तो मैंने उनको एक कहानी सुनाई थी. मैंने कहा सर एक बार क्या हुआ, एक आदमी गया डॉक्टर के पास. He told the doctor, "Doctor, I can't read." Doctor said, "No worries, sit." Doctor made him sit on the chair. Doctor then tested his eyes, gave him specs. बोला ये अभी दिख रहा है. बोला नहीं, अब पढ़ पा रहा, नहीं पढ़ पा रहा. Can you read now what is there on the screen? Increase the power. Kept increasing the power. Doctor reached the highest possible power. Can you read now? He said, "No, I can't read." Then doctor was like, "What can I do now? There's nothing that I can do beyond this." So, doctor, the problem is that I can't read. वो IRS ऑफिसर थोड़ा था. मैंने कहा सर इज दैट द प्रॉब्लम? I can read now. But in your case it was genuine. You could not see.
आप कराया हो, काफी करा था वो, मैंने करा था. इशू है वो,
But we'll sort it out. We'll sort it out.
वो मैंने नहीं करा था. थोड़ा AI
अर्जुन क्या है?
But at least you have done it.
सर
Yes,
मॉडल वाला में कुछ लिखना भी है असाइनमेंट में.
नहीं. You just need to run and tell me what is the result that you've got.
हाँ, ठीक है, वो रन करके अपलोड कर दिया है.
आया result क्या आया?
वही आ रहा सर 33.
Whatever we said was true, right?
Yes.
हाँ. Okay.
Is it visible to the people who are online also? Okay. Now look at the formula that is there on the screen. What is the first part of the formula? What is the first part of this formula? This part of the formula. Wow.
That is equal to formula.
This is your.
This part of the formula so the first part of the formula is talking about what is this? NCR? Right? This is NCR, nothing else. Now, when I am saying that I have, let's say, a question, and I wanted to look at the formula once, and then we'll be coming back to the formula. Let us say that I'm talking about this particular question, where I'm saying that I have to find out. So let's read the question first. Select randomly one team of 3 students from a large pool of students composed of 70% Indian and 30% international. What is the data telling us? Now, how do I go back to? I have to write also. So now you're told that you have to select a team of 3 students. You have to select a team of 3 students, right? And these few students are to be selected from a large pool of students where there are 70% Indians and 30% international students. How are you defining success? The success here is that you pick a international student. Now, what's the probability of success?
30%.
30% or 0.3. Now there are only 2 possible outcomes. Either you will end up picking an international student or an Indian student. If you're picking an international student, success. If you're picking an Indian student, failure. Probability of success is also given. Will this follow a binomial distribution? And I am doing it with replacement. I am not asking anyone to go out. I am just keeping the same population as it is. This follows a binomial distribution, n independent trials. We are selecting 3 students. How many times you are doing this trial? 3 times. Right? And you're talking about 2 outcomes, and there is a probability P associated with the success, which is 0.3. Right? Now, how do I do it, and what is the way of doing it? Now, if I want to find out the probability of finding exactly, if I want to find out the probability of finding exactly, let's say, 1 student, and there should be only 1 student who is international out of these 3. Right? What will be the probability and how will you find it out? Now use this formula.
70.
N is what? Total number of trials. What is the total number of trials? 3 factorial. What is X? 1. Because we want only 1 student who is international. N factorial divided by 1 factorial multiplied by 2 factorial. N minus 1, which is 3 minus 1, that is 2 factorial. P is the probability of success. What is the probability of success? 0.3 raised to the power x, which is finding 1 student. So 0.3 raised to the power 1. 0.7 raised to the power 2. Whatever you get will be the probability of finding 1 student who is international student. Right? You see this example down here? This is exactly the solution. This is exactly what we talked about. Now, probability of finding 2 international students, you put n as 3, x as 2. Probability of finding 3 international students, you can put n as 3 and x as also 3. All of you know 0 factorial is? 1. 1 factorial is? 1. 2 factorial is? 2. Wonderful. Now, there is a slight thing that might happen in this. What is the probability of finding at least 2 students who are international?
1 is.
What do you mean by at least 2?
Minimum.
Minimum 2. That means 2 or
More.
2 or more, which is 2 or 3 in this case. So then you'll have to do it twice with x as 2 and then x as 3 and add them. What is the probability of finding at most 2? Maximum 2 means what?
1 and 1.
No.
1 and 1.
0. 1 and 2. So now you'll have to take 0 plus 1 plus 2. You'll have to do it thrice, which is too much for us to do. Why would we do it? Formulas and all. I don't like. We'll do it using. What will we use? Excel. So let us open our laptop, all of us. You would want to do it with me? Or you just want to watch the movie? Watch the movie? Okay. The formula that we use is binom.dist. Right? The formula is binomial dot distribution. Now in this formula it is asking you for number of successes. Let us say we are talking about a specific case where I want to find out the probability of having at most 2 students. At most 2 means what? 0, 1 and 2. Now, what is the number of success that I want? 2. Right? Upper ceiling is 2. How many trials are there? 3. What's the probability of success? 0.3. Is it cumulative? All of you know what cumulative is? 0 plus 1 plus 2 plus 3. 0 plus 1 plus 2 in our case, because we are talking about 2. If we would have only been interested in finding out exactly 2 students, I would have said cumulative is false. But in this case, I am saying at most 2. That means 0 plus 1 plus 2. So I'll say that I want it to be cumulative. That's it. I want the probability of. Let us check whether the answer that we are getting here and the answer that we saw on the screen is same or not. What is the probability of finding exactly 1 student who is international? So what is the number of success? 1. How many trials were there? 3. Success probability was 0.3. Is it cumulative? No. I just want to find out the probability of finding exactly 1 student. And then I see that the probability is 0.441, which is exactly the same as what we were getting in the slide, 0.441. Is this clear? Can you guys find out, all of you have your laptop, can you guys find out the probability of finding 3 students who are international? Exactly 3 students who are international. 3? हाँ 3 में से 3. तीनों के तीनों इंटरनेशनल होने चाहिए. 0.00
plus 0.3.
0027.
0.02.
0.027.
0.027.
0.3.
मल्टीप्लाई करने में गलती करी आप.
0.3.
आपने बिना इसके किया है 0.3 into 0.3 to 0.3, which is okay. You can do it for simple questions, but then what if the number would have been, let's say, 15 trials, 20 trials, and all? Then you would have used Excel. So it is always good to use Excel. You get in the habit. आया जी आया सबका आया. करके देख ले. Is equals to binom.dist. I am saying what is the probability of finding 3 international students out of 3 students that I select. So number of successes 3. How many trials am I doing? 3. Probability is 0.3. And then I am saying that this is false because I am finding exactly the probability of having 3 students. 0.027. Can you tell me the probability of finding at most 3 students? 1. 0 plus 1 plus 2 plus all the cases are covered. I want you to now solve another question which is like this. इसका आप सिर्फ D part करिए अभी. Only the last part. A laser production facility is known to have 75% yield. You can read this, right? Sorry.
Shift F5.
किसके लिए? Question नहीं दिख रहा है.
अब दिख रहा है.
वो चला रहा है क्या? I'm like, no, I showed the student. I went on. Somebody is the controller. Seems. A laser production facility. आप पढ़िए. Why should I read it for you guys? You don't mind me having coffee, right? The rule was you can have, I can have. What is defined as success?
Already done. 75 points.
Success is getting a laser which is working, and the probability of success is 75%. How many trials are there? And how many successes do I want in part D?
At least
14
14.
and 15.
So 1 minus 15 out of 50.
What is at least 14?
All but all
14 or 15.
14 or 15. So you can do it in two ways. Either find it for 14 and add it with what you get for 15. Or find it for 13 and subtract it from 1. समझ रहे हैं मैं क्या कह रहा हूं? मैं भी करता हूं आपके साथ साथ. Let us see who does it first. My system is. Somebody else has control of my system. So we're talking about number of successes as 14. Out of 15 trials, the probability of success is 0.75. I am not saying it is cumulative. Cumulative is false. I close it and then I do the same thing for 15 as well. And then I find the sum of both. 0.080.
Do you mind going to the question again?
Yeah, I don't mind. A laser production facility is known to have 75% yield. That means out of all the lasers produced, 75% will be working fine. That is 75% laser manufactured by the
So
facility.
you did binomial distribution 14, 15. What did you think is probability?
Probability is 75%. It means because out of all the lasers that you are producing, 75% are working. It was moving one. So this is clear, right? Now let us see if the answer is same when we are doing it the other way around. What was the other way around? We said that we will be finding out the probability for 13. So binomial dot distribution. Here I will put successes as 13. The number of trials will be 15 still. Probability of success will still remain as 0.75. And I am also saying that this is now cumulative. Why? Because I will take all the cases from 0 to 13 and then I will subtract it from 1. And 1 minus this number should give me the answer, which is absolutely the same. So that means that the probability is remaining to be the same. Right? Are you all with me?
Yes.
Could you do it? Go ahead, sir. Everybody who's online, are you able to do it? Guys, who are online, please let me know if there's any doubt.
So what did you do the second time?
In the second one, I said there are two ways of finding it. One way of finding it was when you are actually, so because you were told in the question that it is at least 14, right? Now, when you say it is at least 14, let's say I have all these cases where I have one facility, 1, 2, 3, 4, and so on till let's say 15. Now, you want to find out at least 14 are working. That means either 14 are working or all 15 are working. Now, how do I do that? I find it for 14 and I add it with 15. Another way of doing it is that I don't do all this. What I do is that I find it for the first 13. That 13 facilities are, 13 of the lasers are working. So I say that what is the probability that 13 are working? What is the probability that 13 are working? And I subtract it from 1. 1 minus this 13's probability will give me the probability of the remaining 2. 1 minus 13 will give me the remaining 2.
How did you get to the 0.08?
1 minus the probability of 13. So this is the probability of getting 13 lasers working. Yes. Right? 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus till 13. And then I subtracted this from 1. I subtracted this number from 1 to get the probability. Would you want to do one more question?
Yeah.
Okay, I'll just tell you the question. Because there's a lot of war and all going on. The scenario is like this. There are missile detection systems, interceptors and all, right? Now, the probability with which your missile detection system is able to intercept a missile, incoming missile, is 0.9. Is 0.9. And you have two such systems working. You have two of these systems working, each having a probability of 0.9. There's a missile attack. What is the probability that at least one of them will intercept? To the people online, I'm repeating it again. You have a missile interception system. You have a missile interception system. The probability that the system will be able to intercept an incoming missile is 0.9. Now you have two of these systems in place. What is the probability that at least one of them will be able to intercept an incoming missile? Okay, so you have two of these. There's one system, there's another system. Both of them are having a probability of 0.9 that it will be able to intercept. What is the probability that at least one? At least one will intercept.
0.99.
Silent here.
Probability है 0.
How will you define n here? N is 2 because you have two systems, right? There are two trials. What are the trials? One trying to stop and the other one trying to stop. So there are two systems. N is 2. What is the probability of success? 0.9. What is the X value here? At least one means what?
1 and 2.
1 and 2. Either one will be able to intercept or both are able to intercept. So 1 and 2. How can you find this? One way of doing this question is that you do it individually. That is 1 plus 2. Another way of doing it is that you find out 0 and subtract it from 1. Right? Let us do it both the ways. Let us find out for 1 and 2 equals to binary distribution. What is the number of success that I want? 1. What is the number of trials that I have? 2. What is the probability of success? 0.9. And is it cumulative? No.
0.1.
I do the same thing for 2 as well. I'm just changing one thing here, which is 2. I get this. And then I do the sum of
0.99.
both of them, which is 0.99. This is okay. Now, what is the probability of 0? Let us find out the probability of 0, which will be subtracting from 1. 0. Number of trials will be true. Probability of success will remain the same. Is it cumulative?
Doesn't matter.
It does not really matter. Very right.
Zero.
If you put it as true or false or anything, it will be the same because 0 to 0 ही है. Right? एक ही number है. तो आप उसको कुछ भी कर सकते हैं. Let us say because logically it should be false, so I am doing it false. I get this is equals to 1 minus this number will give me the same. Are we good till this point?
Cumulative velocities. Yeah.
Cumulative क्यों नहीं किया इसमें या क्यों किया?
True, false, generally.
In general. Okay. Think of it like this. Let's say there is this bottle that I have. Right? There is some water in the bottle. Starting from 0. Whenever I am asked to find out that at most this much water should be there, that it touches the tap. At most means what? Anything which is below this to this point. Cumulatively from 0 to this point. Cumulatively from 0 to this point. So this is cumulative. True. But when I'm told at least the water should be from this to the cap, then I cannot do cumulative because cumulative always starts from 0. Then in that case, what will I do? I'll say, okay, this plus this plus this, and I keep on adding till this point. Or I say 1 minus this. That will give me this. 1 minus cumulative of this will give me this. So that's what cumulative, and that's how cumulative is working. Either from 0 to a point, and if you're above that point, that means 0 to that point minus 1 minus 0 to that point.
So in this case, we'll
The first
do
one is
cumulative for the second one
Yes.
because I'll start from 0 basically.
Correct. You should actually do 1 minus cumulative of, but it was only 0. It was only one number. That's why we were doing it. Now you will tell me one thing. What kind of data are we talking about? Is this continuous data or discrete data?
Discrete.
For binomial distribution, it is very clear that the data has to be discrete. In fact, I'll go to the extent of saying that it is not only discrete but categorical, where I'm having only two categories, success and failure. Right? So binomial distribution is a kind of a discrete distribution with n number of trials having two outcomes, having n number of independent trials having two outcomes where the probability of one is p and the probability of other becomes 1 minus p. Okay, another thing. When you are talking about head and tail, let's say, head and tail, okay, and if I tell you expected number or mean of head and tail, you're doing this toss 10 times. You're tossing a coin 10 times. What is the expected number of heads?
50%.
50% as in what? You're doing it 10 times, I told you. What is the expected number of heads? If you're tossing a coin, a pair coin 10 times, कितने head आने चाहिए? How many heads will you have at the end if it is all fair?
Maximum is 10.
No. Expected. Expected will be 5. If you're doing it 100 times, 50. Let's say if I tell you that, no, again the same question. In this class, there are 90% people who are wearing black. 90% people who are wearing black. I do this 100 times. Out of 100 times, what is the expected number of times that I'll find somebody having a black shirt? 90. Wonderful. Simply, what you're doing is you're applying a formula in your head. And that formula that you're applying, my friends, is n. The formula is
N into P.
n into p, right? ये हमारी गलती नहीं है. उसको डरना हुआ है.
Hangover.
The formula that you're using is n into p. Right? N is the number of trials multiplied by. So this becomes the mean of a mean or expected value of a binomial distribution. Another thing and very interesting thing, variance. अब वेरिएंस कब ज्यादा होगा डेटा में? जब दोनों इवेंट्स की प्रोबेबिलिटी सेम होगी या दोनों इवेंट्स की प्रोबेबिलिटी बहुत अलग अलग होगी. फॉर एग्जांपल, आई टेक द सेम एग्जांपल ऑफ शर्ट. 99% of the times I'll find somebody wearing a black shirt. Let's say there are 100 students in the class and out of 100, 99 are wearing black. What will be my result? Out of 100 times, 99 times I'll be having somebody wearing black. So the variation is very, very low. But if it would have been 50-50, the variance would have been high. Head and tail, whenever I'm tossing, I'll sometimes get head, sometimes tail, head, tail, head, tail, head, tail. The variance is high. Variance as in what is, the result is changing every time. But if let's say I'm talking about a biased coin, where I get only tails, both the sides are tails. वो जय और वीरू वाला टॉप वो है coin. You remember? You have not watched Sholay. मैं इतना नहीं हूँ. Sholay. So he had a biased coin which had the same head on both the sides. What will be the variation in this case? 0. So I can think of a formula which is telling me that the formula for variance should be nothing but NP multiplied by 1 minus P. Why am I putting this? If they're equal, square is the biggest number that you can form with a number. Right? Probability में आपको दो में sum should be 1. If the sum is 1, and you want it to be the highest, you'll have to divide it into half. Then only it will be the highest, right? You can think of it like this also. अगर 50-50 है 0.5 into 0.5, what will you be getting?
0.25.
Multiply तो कर रही है?
Yes.
0.25. If it would have been 0.9 into 1, 0.9 into 0.1, what would you have got? 0.09. 0.09 is lesser than 0.25. In fact, any other combination will be lesser than 0.25, sorry. That proves that this formula should work. So now you have 3 formulas or you have 3 things that you know about binomial distribution. How do we find out the probability of occurrence of an event in binomial distribution is clear? We use the binom.dist and we know the formula also. NCR 1 minus p raised to the power n minus x and p raised to the power x. Mean formula or expected value formula is p. And variance formula is NP into 1 minus P. If there is any doubt, you can ask. Otherwise, we'll move to the second friend. All good? Wonderful. Now let us move to the second friend. What do you want to be introduced to? You want to be introduced to another discrete distribution or you want to move to a continuous distribution now? Discrete पे ही रखें या continuous पे ही रहें? और continuous पे चले जाएं? कोई नहीं बोल रहा है. Discrete. चलो discrete खत्म कर लेते हैं. So one kind of data set was where there were 2 events, success, failure, and independent trials and all. Another kind of data can be where I am talking about average occurrence in a specific time interval. the number of students sitting in a class, which is for 2 hours, the number of cars parked in the parking area in a specific day, number of people traveling in a bus for around an hour, number of customers coming in my restaurant, right? Restaurant is a very, very interesting case, by the way. Why is restaurant interesting case? Any service premise for that matter. Anybody who's worked in a service premise, hospital, restaurant, कहाँ पे? Hospital. Anyone else? Madam, कहाँ पे काम किया आपने?
Restaurant.
Restaurant. बहुत ही बढ़िया. If you don't mind, can you tell us what was the profile?
What was the profile? I was making pizzas.
You're making pizzas. Wonderful.
I was serving.
Wonderful. Now she'll be able to tell us the biggest problem in a service premise. Let's say, talking to you directly, let's say that you are able to make 6 pizzas in an hour. So it takes you 10 minutes for making 1 pizza.
11.
And I also tell you that on an average, you will have 6 customers coming in your service premise. The question is clear. The example is clear. There are 6 people coming in your service premise, 6 people coming in to have your pizza in an hour, and she is able to make 6 pizzas in an hour. 6 ही बना रही हैं, 6 ही लोग आ रहे हैं खाने. हर आदमी एक ही ऑर्डर कर सकता है. क्या कभी लाइन लगेगी?
हो सकता है.
Yes,
possible
why
है.
not? Maybe.
मैडम आप बताइए.
Oh, yes, because अगर वो सब same time पे आ गए.
आई ये बात. Experience speaks.
Possible.
Experience speaks. Right? You get it? You get it? In service premise, when you say average arrival rate is nothing, okay? Arrival rate is something. Or average arrival. Arrival rate is 6. Service rate is 6. Logically, you start thinking that there won't be any queue because 6 लोग आए, 6 लोग सर्व हुए. But pizzas कब बन रहे हैं? जब लोग आ गए हैं. अब वो 5 लोग एक साथ आ गए. पहले 50 मिनट में कोई भी नहीं आया. Now what will you do? You have a problem. Problem in services is heterogeneity. Somebody, and she can't make pizzas and keep them stored because there's a problem where somebody will say, I want margarita pizza, I want this pizza, farm fresh and this and that. Don't put whatever jalapenos in my pizzas and put this in my pizzas or whatever. Everybody wants it to be customized. I want you to go and search for a term which is known as delayed differentiation. Though I am a statistics professor, but then there is a term which is very, very important for everybody, every manager to understand and know. Specifically for people, for madam, for example, if she's still willing to carry on with the business. Delayed differentiation. चलो मैं ही बताता हूँ, पर फिर भी ढूंढना पड़े ना delayed differentiation के बारे में. One firm that has been doing delayed differentiation since a long time is Subway. What Subway does is all the ingredients and everything is ready. They can customize as per what the customer is asking for. कौन सा आपको चिपोले चाहिए? You want mustard, honey mustard, whatever. You can choose your sauces, not sausages. Sauces. You can also choose your patty or whatever. You can also choose the veggies that are going in. What they're doing actually is it's a delayed differentiation strategy, which is wonderfully used by all the paint companies. Have you looked at the brochure? Right. Girls will be feeling shy after looking at the brochure. They also don't know the shades that are there. Right? Boy, I am 100% sure. In your life, you'll never ever get to know all these things. But then they have a big booklet, Asian paints and all. And that's only one kind of thing. Asian paint primer, 35, 40, 50, 100 shades. Then there is interior, this 100 shades. There, something else, something else, something else. Think of that poor chap who is having a shop. Will he be able to keep all these shades in a... And mind it, people come in with various... Nowadays, in one room, people are putting 2 colors, 3 colors. Right? On ceiling, there's a different color. On the main wall, there's a different color. On the opposite wall, there's a different color and all. So what I'm trying to say is people come in with a lot of variability. Everybody wants a different color. It is not possible to keep that color. How do they do it? They have a main primer base, and then they have very small bottles of these colors. They mix it and give it to the person there and there, and then they pack the bucket there itself. What they're also doing is delayed differentiation. You come in, you tell us what do you want, we'll make it right now. That is delayed differentiation. Now, why are we talking about all this? Because in service premises, again, the problem that madam told, that you do not know how many people will be coming in, and even if you know it, still it becomes very, very difficult to plan things in that manner. All these examples are examples of Poisson distribution. Poisson. Right. What is the Poisson distribution? Poisson distribution is a distribution that is characterized as follows. In a Poisson distribution, you will have an average occurrence of events. You will have a rate of occurrence of events in a specific time interval. You will have average occurrence of events in a specific time interval. How do I make this big?
Escape दबा के shift F5.
Sorry?
Escape,
Back. Oh, escape दबाकर
shift F5.
मेरे ख्याल से इससे भी वही काम होता है जो एक नीचे एक प्रेजेंटेशन वाला बटन
हाँ वही.
चलो कोई बात नहीं.
आपकी स्क्रीन दिखा रहे प्रेजेंटेशन नहीं दिखा.
Anyway, who needs slides? So, what we were talking about average occurrence or average occurrence of an event in a specific time period. Let's say, for example, number of births in a hospital. एक hospital में एक time period में, that time period can be anything, an hour, a day, year, whatever. But we're talking about a certain time interval. Average occurrence of anything in that certain time period. Now, the question is, can this average occurrence be in decimals? देखिए फर्क है average occurrence और number of occurrences में फर्क है. When we were talking about the number of people coming in the restaurant in a specific time period, it has to be a integer number, 5, 6, 10, 12, 15, 30, whatever. But we're talking about average occurrence. Average occurrence can very well be in decimals. In the first hour, you had 6 people coming. In the second hour, you had 7 people coming. Average is 6.5. The average can be in decimals also. So we are talking about average occurrence in a specific time period. This is the most beautiful distribution in terms of simplicity, I'd say. Why? Because the formula is very, very simple. What does the formula look like? E raised to the power minus lambda. Lambda raised to the power x divided by x factorial. I want you all to look at the formula very carefully and see that there are only 2 things which are variables here. Lambda and x. E is nothing but 2.71 something. It is a constant. Lambda is what? Lambda is given to you, which is the
Average.
yes, very good. Average occurrence or occurrence rate of an event. X is what you need to find out. That's it. What you need to find out, as in, let's say if I tell you that in her restaurant, on an average, there were 8.2 people coming in an hour. 8.2 people coming in an hour. What is the probability that she will have 10 people coming in a specific time period? अब on an average कितने आ रहे थे? 8.2. क्या इसका मतलब ये है? It does not mean that if she is saying that there are 8.2 people coming on an average means that there will be only 8 people or 9 people or 8.2. There will be times when there will be nobody coming in. There will be times when there will be 50 people coming in, 20 people coming in. She told you exactly that there will be 6 people coming in at one point in time also sometimes. So there is a huge variability. But then the variability will, or the number of, as you start moving away from the average, the probability should go down. If the average is around 8.2, probability of 100 people coming in will be very, very less. Are you guys getting what I'm trying to say? The probability will be higher around this mean number only. Right? Yes or no?
Yes.
Remind me of this particular example when we talk about CLT. Okay? But remember this. Now, this is clear. Should we start solving? One thing is very clear. What is the expected value or the mean value in a Poisson distribution? Mean is given. Average number of occurrence, lambda. Expected value will always be lambda. Right? Now let us do this question. Let us do a few questions on. Let us look at this. Births in a hospital occur randomly at an average rate of 1.8 births per hour. This is possible?
Yes.
Average rate is 1.8 births per hour. In 10 hours, how many kids will be born? 18 in that specific hospital. Right? Now you are being asked the probability of observing 4 births in a given hour. अब भैया आपको पता है कि एवरेज कितने हो रहे हैं?
1.8.
आपको कितने का निकालना है? चलो जी. It equals to Poisson dot dist. What is x here? 4. What is the mean that is given to you? 1.8. Is it cumulative? No. We were never told at most, at least, nothing of that's what came out. It is exactly 4. So we'll say it is false. Close the bracket. 0.07. As simple as Madam के restaurant में चलते हैं. Poisson distribution again. She was getting on an average how many customers? 8.2. What is the probability of getting? 10. 10. When the average was 8.2. Cumulative false. 0.1. What does this tell us? It helps us plan our service premise better. If I know that there is only 10% probability, 0.1 is 10%. There's only 10% probability of having 10 customers. I still might want to design my facility for 10% probability. But I would not want to design my service premise for a 1% probability. So I can see where am I getting 1%. Right? Let us see. If I want, I can see that, okay, if this number would have been, instead of 10, if it is 15, what's the probability? I am getting 1. Right? I don't want to design my facility for this 1%. 100 में से किसी एक दिन 15 लोग आ जाएंगे एक घंटे में. मेरी कैपेसिटी भैया मैं 10 पे रख लूंगा, 12 पे रख लूंगा. मेरे को नहीं चाहिए 15 लोगों की कैपेसिटी. Because capacity expansion or capacity, increasing the capacity means investing more. I don't want to do that. This is a managerial insight from this particular thing right now, right in front of us. Am I going fast? Now let us look at a few of the, okay, you look at this also. What is the probability of observing more than or equal to 2 birds? What are we talking about? More than or equal to 2? More than or equal to 2. Now this is a tricky situation. Why? Because more than 2 birds can be how many? Can be infinity. So the easier way is you find out the probability of having 0, 1, subtract it from 1. Right? So in this case, what will I do? I'll say that the probability of Poisson distribution, probability of finding 0 and 1. That means I will say 1. And what will I do? 1.8. And then I will say that this is cumulative.
Yes.
Because it will include 0 and 1 both. So I'll do this and then I'll say that subtract this number from 1. 1 minus this number will give me the probability of having 2 or more kids getting born. Are we good, madam? Are we good? Not good. You can tell me if you're not liking this. I'll explain everything from scratch if you want. Sure, no?
Can you walk us through the chart, Poisson distribution chart?
We'll look at all the charts together. We'll look at all the probability distribution charts together. Right. In fact, we'll also talk about their sampling techniques and how do you draw samples from there. But then one thing is clear. If you just think of logic, what you'll observe is it will be highest towards the mean. And as you're moving away from the mean, it should come down. It should look not exactly, but quite similar to normal. But we'll come to all the charts for that matter. We'll be, for binomial, it is simple. For binomial, it is, and again, the only thing is, and I don't know why every time I'm going more towards CLD. The only thing is you have a lot of, see, I'll tell you, Poisson is again a discrete distribution, right? The main difference between discrete and continuous distributions is, continuous distributions will have an area covered under them. May it be uniform, may it be normal, it will have an area covered. But discrete distributions should not have an area covered under them. Right? It is either this or this, either head or tail, both having equal probability. So it is either, I should not put this bar actually. Right? It should be either this or this. If I'm talking about this also, it should be like this. Right? Should be like this. But then why do we put a curve on this is what we'll be looking at now. Let me do one more. In the last class, we did uniform distribution. Did we?
Yes.
Did we discuss about this distribution where I said that, okay, 2 discrete distributions we have done, that is binomial and Poisson. We'll move to continuous distributions now. The first one that we're talking about is the uniform distribution, the simplest of all. Yes, sir.
So when we were discussing about binomial distribution, I was a bit lost. So I just wanted to know, would we need these like pen and paper formula?
No. I promise this is the first. No pen and paper formulas. You'll do it on Excel. If you want, you can. I will not stop you, but I will not ask you to use pen and paper to solve anything. You will have Excel. जिंदगी में Excel है. अब तो GPT भी है. तो GPT यूज करो, मुझे कोई दिक्कत नहीं. Understanding is important, right? And that's the idea. You guys are not kids now. Why do you? मैं सिर्फ इसलिए दिखाता हूँ जिससे तुम्हें ऐसा ना लगे कि इसको भी नहीं आता है. Otherwise, I have no interest in making you guys go through torture. So we are talking about normal. We are talking about uniform distributions. In a uniform distribution, what happens is that let's say that there is an example where I'm saying that you're standing at a metro station. I think we discussed it in the last class. No? You're standing at a metro station, and after the first metro, the second metro comes at least after 2 minutes, but definitely comes before 6 minutes. This I'm telling you. अभी एक मेट्रो गई है, अगली मेट्रो 0 से लेकर के अभी गई है तो 0 से टाइम शुरू हुआ है. From 0 to 2, the probability of another metro coming is 0. But from the second minute till the 6th minute, it can come any time. Okay? It can come any time. And the probability is same throughout. That means in these 4 minutes, the probability is remaining the same throughout. I want you all to write one thing if you are writing anything anywhere. If you are not and if you are watching the movie, you may. The thing that I want you to write is area under any curve. Area under any curve is equal to 1. Now, if we know this, then you can do what not with this particular distribution. And it is a simple distribution. There's nothing to discuss about this distribution. What is the probability that you will get the train between 4th and the 5th minute? अब ये बताइए कि पूरा 1 है जी. कितने यूनिट्स में पूरा 1 है? 4 units is equals to 1. You are talking about 4th to 5th minute. 4th to 5th minute. How much of this is there? 1 unit. If 4 units is 1. If 4 units is 1. That means 1 by 4 in every unit. Multiplied by 1, 4 to 5 is. So you get getting 25% probability the train will be arriving between 4 to 5th minute. As simple as that. Formula क्या हो जाएगा जी? 1 upon B minus A. This is B, this is A. 1 upon maximum minus minimum multiplied by the number of units that you have, which is X. X upon B minus A. This is, I am not much interested on. You will never, I won't say never, but then very seldom find such distributions where continuous data is having equal probability. I'm not saying it is not there. I'm not saying that, but I have not come across many cases where we use uniform distribution. Generally, when we use it, when nothing is clear, we say that for simplicity, we are going ahead with a uniform distribution. But then simplicity is not right. Now we come to the most interesting, the most popular, the most used, the best of the best, my favorite. Everybody's favorite, in fact. Normal distribution. The most talked about, the most taught, the most whatever. Right. And I will start this with a theorem. And the theorem is known as, again, please note it down. Central limit theorem. I have been having this itch to start this, talk about this theorem since a long time. Poisson distribution की बात करें तभी मेरे दिमाग में बार-बार आ रहा था. I told you about an example that you were to remind me from Poisson. What was that example? I forgot. Exactly. What was the?
Like 8.2 people coming and then.
Yeah. Oh yes. Yes. Now I remember. Okay. Now, what is central limit theorem? I will show you with 2 examples. First, we'll convert a binomial to normal, and then we'll convert a Poisson to normal. Okay. What do you think? Rolling a dice. Rolling a dice is a discrete distribution. All the things are having same probability. Rolling a dice. Yes. Either it will be 1, 2, 3, 4, or 5. Discrete distribution, not a continuous distribution. Let's say I randomly roll a dice. Not bad. Ran between. What are the numbers you can get on dice? 1 to 6. One assumption that I have when you're doing this course is that you know basic Excel. Generating a number between 1 to 6 random between them. I should not explain the formulas that we're using. I am doing this 10 times. Okay. I am rolling a dice 10 times and all of us are rolling this dice 10 times. I roll it 10 times and he rolls it, you roll it, you roll it, everybody is rolling it. How many of us are here? 14. 14 is what, N? N. Then everybody. So A is me, B, C, D, all of us have rolled it. Can you tell me what is the expected value of a dice? Expected value, mean of a dice.
1 by into
1, 2, 3, 4, 5, 6. Add them all divided by 6. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. 7 into 3 is 21. 1 plus 6 is 7. 2 plus 5 is 7. 3 plus 4 is 7. 7 into 3 is 21. 21 divided by 3 is 21 divided by 6 is 3.18. 6 5 is 30. 3.5. So what I'm telling you is if I roll a dice 100 times, the sum should be 350. होना तो यही चाहिए लॉजिकल. अब देख लेते हैं जी इसका एवरेज क्या आ रहा है हमारे. Let us see if the average of these numbers is around that or not. Oh, 3.2. Okay, this is mine. Let us see what about others. Unless I don't freeze it, it'll keep changing. The way to freeze this is maybe you can just Control C and paste as special.
all TS.
Then you just paste the numbers. Done. Now it will not change. Now what has happened here is, I want you to focus on these numbers. The minimum that you're getting is 2.7, maximum is 4.4. And what is the average? 3.7. Close to 3.5. Right? Maximum that it has gone up to is 4.4, minimum is 2.7. What has started happening? This was not a normal distribution, by the way. But then the mean is 3.5. And now you're getting values around 3.5. 3.9, 3.6, 3.9, 3.6, 3.9, 3, 3.7, 3.7. You are starting getting, and if I do it more times, I'm sure if I increase the number of times I'm rolling it, if I make it 20, 30, 40, 50, it will become even closer to 3.5. I will keep getting closer as the number of samples increase, the law of large numbers will kick in. Law of large numbers. What is law of large numbers? As the sample size increases, the parameter, the parameter starts becoming closer to the population parameter. The sample parameter becomes closer to the population parameter. Now, irrespective of what distribution I took the sample from, irrespective of the distribution, this was whatever distribution, I don't care, continuous, discrete, binomial, Poisson, whatever, irrespective of where I am taking sample from, the sample means, this is the sample mean, the sample means will follow a normal distribution. Are you getting what I'm trying to say? Irrespective of where I get the samples from, the sample means will follow a normal distribution. Poisson data. Now the mean is, let's say I start taking mean every day. How many people came in the restaurant today? How many people came for second day, third day, fourth day, fifth day? And let's say the average is 8.2. What you'll observe is that daily it will be around 8.2 only. Sometimes it will be 8.4, sometimes it will be 9, sometimes it will be 10.5, sometimes it will be 11 also. Sometimes it will be 7.6, 7.5. But then as you are going away, the frequency will go down. Right? Starts looking like a normal distribution. So the means are following a normal distribution. This particular thing is known as the central limit theorem. Central limit theorem. Right? Now, because of this very powerful theorem, what I can do is, if I'm drawing samples, irrespective of what population it is coming from, if I'm drawing samples, and if I am doing a hypothesis testing on those samples, I can definitely follow a normal distribution test and all. Right? So normal distribution, that's why is a very, very powerful distribution, because irrespective of where you're getting the data, the means will follow a normal distribution. Now let us start talking about normal distribution. The time is 10:42. We have 15, 17, 18 minutes, 18 minutes. So we'll not do the quiz today, we'll do it next time. There was a quiz, but we'll do it next time. Maybe not next time. Maybe never. God knows.
That's right. No.
So, what I will now start with is a normal distribution. Is it okay if I do it here? Now, this is what a normal This is what a normal distribution looks like. It's a bell-shaped curve, and this bell-shaped curve always has the mean in between, which is represented using mu. And another important parameter that you need to look at is sigma. Mu and sigma. Mu is the mean, sigma is the standard deviation. These two things define a normal distribution. You all know what happens when the standard deviation is high, when the mean is shifting, this and that. All those things are very well known to us now. We are quite comfortable with that. One thing is clear, as we are moving away from the mean, the probability is decreasing. I want you all to think of this as a bucket. And think of it as a bucket, a hat, or whatever, which is kept in an inverted manner. The number here on the extreme left is always the minimum value. It is the minimum value. The number here on the extreme right side is always the maximum value. That means I'm saying that the numbers are increasing from here to here. At this point also things are okay. Numbers are increasing from here. Not only the numbers, the cumulative probability, all of you know, starts from 0. So the probability is starting from here. And as we move, the probability is also increasing cumulatively. Right? You all know what is the probability under a curve?
1.
The entire thing, the entire area covered is 1. If it is a symmetric curve, symmetric means 50% of it is this side, 50% of it is this side. If I fold it in half, it will coincide together, the edges. What should be the area covered under this side?
0.5.
0.5, 1 by 2, 50, whatever. And it will be the same as this side. Right? So this thing is clear. Till this point, we are all good. Like, why am I going slow and why am I asking so much? Is because this is very important. If you don't get this, your hypothesis testing will go for a 6. So you need to be very, very, very. If you have not got anything till this point, okay, I am happy. Not happy. I'm okay. I'll not hold you responsible. Maybe problem was with me, but then I know that I teach this well. Huh? So don't do anything wrong here. Now, this is a bell-shaped curve, symmetric from the mean, equal probability on both the sides. All the things are good till this point, right? Now, all of you also know, we discussed in the last class, I remember, we go one standard deviation on this side, one standard deviation on this side. We can go 2 standard deviations on this side, 2 standard deviations on this side, 3 standard deviations on this side, 3 standard deviations on this side. And we are covering more and more area as we are moving away. This also is clear to you guys. I know we discussed it in the last class. 2 standard deviations, 3 standard deviations, 3 standard deviations. Now, the main question is, let's say if I talk about a specific point X here, how much area have I covered is something that I want to find out. How will we find this out? Now, because this is a curve which is not a very well defined shape, ये कौन सा shape होता है? ये तो हमको किसी को नहीं पता है. हमको ये पता है circle होता है, हमको ये पता है square होता है, हमको ये पता है rectangle होता है, हमको ये पता है, we know this is the triangle. But what is this? Right? This is not a very well defined, this is not a standard shape. Whenever you don't have a standard curve, you end up taking help of integration. Right? But we promised, I promised, we will not be doing anything integration and all by hand and all. What will we use then? Excel. Right? But I'll also introduce you to something which is a very traditional way of doing this, which is a Z table. Now, when I say Z table, first of all, what is Z and what is this table I am talking about? All of you have seen that movie? No, yeah, I'm sure. All of you would have seen Iron Man. Iron Man, second part. There was somebody created. Who was created? Iron Man's father was a scientist. He created a man. Whom did he create? Mr. Captain America. Right? Captain America was created by Iron Man's father. What was the logic and what was the reason? What were they doing? They were trying to create a super soldier. They were trying to create an ideal man. Right? Ideal man. Somebody who is like Captain America, who is flawless in every sense, powerful, this, that, and all. And somebody whom you would want everybody to be like. So we also have a Captain America in standard deviation, in a normal distribution, which is exactly looking like other normal distributions. Captain America also looks like other, but then has different properties and characteristics. What are the different properties and characteristics? Arey yaar, I'm bad at drawing also. Okay. All my life I kept preparing for doing things on board. Suddenly things come out of syllabus and I have to do things here. Okay, this is a normal distribution which we call as standard. I want you all to write it somewhere. Standard normal distribution. Standard normal distribution is a special case of normal distributions with mean mu is equals to 0 and standard deviation is equals to 1. This is the hero of normal distributions. This is the ideal normal distribution with mean 0, standard deviation 1. I want you all to remember this. Even if somebody wakes you up and sleep and asks you, what is the standard normal distribution? You should be able to tell. Standard normal distribution is a distribution, is a normal distribution with mean 0 and standard deviation 1. And scientists, I would like to call them scientists. I'm also one of them then. Discussed and they solved the integration problem that we were talking about. You want to see how it looks like? So you need to play with the equation for normal distribution that looks like this. This. Right? You need to integrate it again and again in order to find the area in the curve. You don't know how to do that, obviously. So what scientists did was, they said that, okay, for this standard normal distribution, we'll create a table. Which is known as a Z table or Z table. Now, what is this Z and Z first of all? On a standard normal distribution, when you say that, okay, what are these points? These points are known as Z, right? Z values. Now, if you're moving one standard deviation, so what is the Z value? Instead of mu, now you start calling Z. So what is the Z value here? 0. All of you can tell me what is the value of, what is the probability at Z is equals to 0?
50%.
50%. Let us go and see it in the table. When Z is 0, where is 0?
Degrees of freedom.
Down here. There is nothing known as minus 0, okay? This is just for illustration purpose. What is the probability? 0.5. If I'm on the positive side of things, here also I have 0 as 50%. You see this?
Yes.
Right? So Z value of 0 is a probability of 50%. Now you tell me one thing which is logical in nature. If I'm moving towards this side, the probability will increase or decrease?
Decrease.
Increase.
Yes.
Because I am filling more and more.
50
Cumulative probability of problem.
अच्छा मैं बीच में आ रहा हूँ.
We have that.
right side take it.
कोई बात नहीं मैं बीच में उधर थे. When we are moving on this side, the probability will decrease. Now, as Z is becoming more and more negative, the probability will decrease. 0 to -1, -2, -3, you're moving further on that side. You're moving more and more on this side. Z -1, -2, -3. Probability is decreasing. But when Z is becoming more and more positive, it is increasing.
Cumulative
1, 2, 3. Cumulative probability. Let us see if it is true in the table. In the table, when I'm becoming more and more positive, from 0 to 0.1, it has increased. 0.2, it has increased further. It will keep on increasing. When Z value is 1, it is 84.13 something. Right? Come down. And if you see, when you go to 2, it is 97. Right? Till the end, it almost becomes 1. Till 3.09. Now, how do you read this table? Can you tell me the probability when the Z value is 1.72? 1.72. Now, first decimal is here. So 1.7 I will find here. 1.7. and 2 is here.
0.9573.
So 0, 1, 2.
9%.
0.9573. Can you tell me the Z value when the probability is 0.71?
0.7.
7611.
7611, 0.7, and then 1. First decimal is here, second decimal is here, right? Can you tell me the probability when the value is 2.06? So 2.0 should be here, and then 0, 1, 2, 3, 4, 5, 6. 0.9803. Are you all comfortable? Similarly, can you tell me the Z value when the value is, let's say, negative 1.96? Negative 1.96. Negative 1.90, 2, 3, 4, 5, 6. 0.250. 0.0250. Right? 2%, 2.5%. This is good. Now we have done a very good thing, and I'm thankful to you guys that you got this in the first go. Everybody's got this, right? If you've not got this, please let me know, because if you don't get this, things will be difficult for me also. निकालना आ गया जी. अब सवाल ये आता है, अब ये तो आसान हो नहीं सकती है लाइफ. Life cannot be this easy that you just get a Z value and you go and find it in the table. How will you convert a normal person to Captain America, or how will you compare this? So I should have a mean and way to convert any distribution in this world to a normal distribution, to a standard normal distribution. So now let's say that I have this distribution. This is your height data. Height, let's say mean height of this class is, let's say, okay, don't take it otherwise, 5 feet. Let's say mean is 5 feet. And let's say standard deviation is 0.5. Possible? Possible. And I'm now asking you that what is the probability of finding somebody with height 5.4 inches? 5 feet and 4 inches. How do I find this? First of all, I have to convert this into this. How can I find Z value? The formula is simple. Z is equals to
X minus mu.
X minus mu upon
SD.
sigma. What is X? X is
5.1.
this number that you are interested in. 5.4. 5.4 minus mu. What was mu? 5. 5.4 minus 5 divided by sigma. What is sigma? 0.5. Which is 0.4 by 0.5. What is 0.4 by 0.5? 0.8. I know that the Z value is 0.8 now. And then I can go and look into my table. That the Z value associated here is 0.8. Can you tell me what is the probability at 0.8?
8.81.
0.7881. So I know that the probability of finding somebody with height less than or equal to 5.4 in this class is 78%. Wonderful. Are you guys okay with this? Can you find out the probability of finding somebody with a height of 4.8 inches in the class? 4 feet and 8 inches in the class. In the same distribution.
65.5.
How will you do it? 4.8 minus 5 divided by 0.5. That is 0.2 by negative 0.2 by 0.5, which is negative 0.4. Negative 0.4 we'll find in the table. Negative 0.4, my friends, is
34.
0.3446. Right? Is there, please ask.
What's in the denominator?
Denominator में sigma था 0.5. Sigma, the standard deviation. Denominator had the sigma. If you are okay with this, if you are okay with this, we'll move ahead. Shall we? Can you tell me the probability of finding somebody with a height more than 6? More than 6. Now, what does more than 6 mean? I am talking about something which is beyond this.
Beyond.
More than 6 ना 6 के आगे जाना चाहिए ना तो पहले Z वैल्यू निकाल लेंगे यहाँ पे Z वैल्यू तो निकालो क्या है जी 2 कैसा आया भाई 6 minus 5 divided by 0.5 which is 1 upon 0.5 which is very fast which is 2. Now if Z value is 2, what is the probability? Now
1 minus.
at Z is equals to 2, let us find out the probability. At D is equals to 2, the probability is 0.9772. Now what you're telling me is 0.9772 is this.
2.2.
This is 0.9772. But you're interested in finding this. So what will this be? 1 minus 0.9772. Yes or no? Right? Also, you can find out the probability of finding somebody with a height between 5.1 to 5.2. How will you do it? 5.2 पे निकाल लीजिए. Whatever you're getting at 5.2 minus whatever you're getting at 5.1, so you'll be getting 5.1 to 5.2. Now, what if I tell you all this is futile and waste of time? Because you have Excel, right? Let us see if you can do it using Excel. What are we talking about? This is a normal distribution is equals to norm. I still have time, right? 2 minutes. This is known as wonderful utilization of time. See, so perfect. Norm.dist. What is the x value? Let us say we are talking about 5.4 example only. So x is 5.4. What was the mean? 5. What was the standard deviation? 0.5. Are we talking about cumulative? Yes, we will always talk about cumulative in this case. I'll tell you what is false also, but let me do this first. 0.788. That is exactly what we were getting. What is the probability of finding somebody with height more than 6? More than 6. Now is equals to normal distribution again. More than 6. X value will be 6. Mean is what? 5. Standard deviation is 0.5. Cumulative, yes.
7.
And then 1 minus. This will give me probability of finding somebody with height more than 6. Are we good? In fact, there is one more formula that I want you to know. I just want you to know. I'm not saying that you should remember this because that formula is almost futile, but then you use it some other places. You must have heard that we'll standardize the value. When there's so much variation and all, we say, well, let's standardize. How do you standardize? This z value is nothing but standardized value. Standard normal distribution gets a standardized value, which is known as z value, and we use the formula standardize. Standardize. What is the value on z table when x was 5.4, mean was 5, standard deviation was 0.5. 0.8. Right? What was the value standardized? Value of z when x was 6, mean was 5. Okay, 5. And standard deviation is 0.5. So I don't need to do anything with pen and paper. I can use this. I can find out z value and then I can go and read the table. Or I don't even need to read the table because I have this and it is giving me the probabilities directly. Now, if I want to find out the probability between 5.1 to 5.2, how will I do it? Very easy. Is equals to normal distribution. पहले 5.2 पे निकाल लेते हैं. Let us find 5.2. What is the mean? 5. 0.5. And then true. ये आ गया जी 5.2 पे. I'll do the same thing for 5.1 as well. This is at 5.1 is equals to 5.2 minus 5.1. This will give me the area between 5.1 and 5.1. So probability of finding somebody with height more than 5.1 but less than 5.2 is 0.76, 0.076 or 7%.
Is there a case in which we do not accumulate in this?
Oh yes, wonderful. Thank you so much for asking. First of all, why do we? What is in a? It's a rule, and I'm sure some of you would already be knowing about this. Whoever knows integration will definitely know this. This is for me to tell me that the class is over. So there's a rule which says that point probability in a continuous distribution is always 0. There is no meaning of point probability. You always talk about probability in a certain range area when you talk about continuous distribution. But what does this tell us? If I say that I would have made this a false, means I get the height. So if I say that this is not cumulative, I'm just talking about this particular thing. So I get this height. The height is something that I get when I say false instead of true. So what is this false? This false is nothing but the height of the curve at that particular. That's it, nothing else. Right? So height will be maximum when the when you're talking about me. And then it starts reducing as you go towards to the end. So this brings us to the end of this session. What have we learned in this session? We have learned
Binomial.
two types of continuous distribution, uniform and normal. Two types of discrete distributions, binomial and Poisson. Yeah. Yes, sir.
What does the height give us?
It just tells us the frequency, nothing else. That's not, we generally don't use it also.
Curve.
Yeah, height of the curve at that particular point. That's it. This is the frequency.
Is there not equal to or just less than? Like,
That's the height.
for the other thing that we are discussing,
Less than or equal to.
less than. If you want
Till that
less
particular.
than.
See, again, when you're talking about continuous distribution, point does not make any difference. So you can say that this is less than, equals to, greater than, almost the same. Right? Or if you want to, you can specify 1 point. So let's say if you're talking about less than 2, you can say 1.99999999999.
No, will be
It will be the same only. Won't be any different.
And what if the question is probability of having people at like 5.4 exact?
There's no probability of having people exactly at 5.4 in a continuous. That's what I was saying. In a continuous distribution, point probabilities are always right. Are we good? So the class gets over with this. And again, I would want to thank you because whatever we have covered in this one class today, it generally takes 2 to 3 classes to cover that much. So we started with sampling. We discussed sampling. We've discussed CLT also. We discussed central limit theorem. We discussed 4 distributions in one class. But good. I am happy and impressed with you guys. You're doing good. But please work after going back. If you will not revise, if you will not do questions, and you can think of questions yourself, you can just do things and apply them. We'll also send you some practice questions. But please practice. If you won't practice, you will lose all these things. We have just used some 3 formulas in the class today. Binom.dist, Poisson.dist, and standardize is okay, one more. So 4 formulas. And we have used normal.distribution. But we'll be using this normal.distribution a lot in hypothesis testing. And the idea again is I don't want you guys to use pen and paper for doing hypothesis testing. We'll be using Excel again. And next class, we'll start with confidence interval and hypothesis formulation. We'll try and do hypothesis tests also because we are left with 2 classes. Last class will be regression. So yeah, so we'll again be just rushing a lot in the next class. But is the pace too much to follow? I hope it is not that much to follow. A little bit I can understand because we have. But I could have done one thing. I could have just skipped a few things. I could have skipped these distributions, but then I did not want to. I wanted to cover them. Right. But please practice after going back. How many of you read the bias thing? एक बार भाई सब नाम लिख दे। अबे तुम आधा पढ़ के
आधे नहीं
तेरी बात है। पक्का? अच्छा तुम्हारा अबे
उसने तो पढ़ा है पढ़ा
कहाँ से पढ़ा भाई?
ऑनलाइन ही पढ़ा था उससे डिस्कस भी किया था कल
साथ नहीं पढ़ा था
और अब तो मैंने भी पढ़ लिया
लेकिन
लेकिन अब तो मैंने भी पढ़ लिया
निश्चय परिमल असीम राघवेंद्र हार्दिक बाकी सबके कट गए
ऑनलाइन वाले
ऑनलाइन सबके 0 है मैंने पूछा था nobody said is there anybody online who has read
अब तो सब
nobody has read thank you okay take care bye bye thank you
Stop sharing or 1 minus this